In the video lecture, we will further continue the multiple choice question from the chapter Atomic Structure. MCQs number 16. The maximum number of electrons that can be accommodated in an orbit is 2n, n square, 2n square, and 2n plus 1. So the maximum number of electrons that can be accommodated in an orbit is given by the formula 2n square, where n is the number of orbit. So among these options, C is the 2n square. That is the correct answer. The maximum number of electrons in the outermost orbit is 2, 8, 18, 32. According to the octet rule, which states that the outermost shell in an atom cannot have more than 8 electrons, even if it can take up more electrons. Thus, the maximum number of electrons that can be present in the outermost shell of an atom is 8. So, 8 is the correct answer. If r is the radius of first orbit, the radius of the nth orbit of hydrogen atom will be n square r, nr, n divided by r divided by n. We know that radius has formula that is equal to 0.529 n square divided by z, where n square is the orbit number and z is the atomic number. So for hydrogen and for first orbit, z is equal to 1 and n is equal to 1 for first orbit. So putting their value in this equation, we will get r is equal to 0.529 angstrom. For nth orbit, we will find it for nth orbit. So Rn is equal to 0.529 angstrom, n square divided by z. So it is, the z is equal to 1. So we will not put over there z, because for hydrogen atom z is equal to 1. N square here is not equal to 1 because it is nth orbit. It may be 2, 3, 4, whatever may be, it is nth orbit. So 0.529, that is equal to r. Here from this equation, r is equal to 0.529. So in this formula, instead of 0.529, we will put r1, radius of first orbit, or we can also put r. So Rn, the radius of the nth orbit, it is equal to r, that is 0.529, that is for r1, and n square is from formula. So the answer is n square r. The ratio of radii of second and first orbit of hydrogen atom according to the Bohr model is 2:1, 1:2, 4:1, 1:4. So we will solve it. Radius is directly proportional to the square of n. So the radius of the second orbit, it is equal to 0.529 multiplied by n square. And the radius of the first orbit, it is equal to 0.529 multiplied by n square. So we will find their ratio. So we will divide it. So the ratio is between second and first orbit. So the second orbit is divided by the first orbit. Similarly, the radius formula is from the second orbit is divided by the first orbit. 0.529 and 0.529 will cancel out. We will get 2 square, that will result in 4, and 1 square, it will result in 1. So 4:1, that is the radius ratio of second with respect to first orbit. That is the correct answer. The idea of stationary orbit was first given by Rutherford, J.J. Thomson, Niels Bohr, Max Planck. So the Niels Bohr was the scientist who proposed for the first time the concept of stationary orbit in 1913, which is now called the Bohr atom or Bohr model of atom. And it will produce the stability because the atom electron can stay in an orbit and a discrete energy orbit, that will produce the stability. So Niels Bohr was the scientist who will give the concept of stationary orbit. Which one of the following electronic transition in hydrogen atom will require largest amount of energy? From N1 to N2, from N2 to N3, from N1 to infinity, from N3 to N5. As the energy level increases, the energy gap decreases progressively. So the maximum energy for an electronic transition is required when the electron jump from N1 to N2. So as we will move to the upper side, or as we'll move to the higher energy levels, the energy gap, the energy difference between the level decreases. So the level that are closer to the nucleus, that will have maximum energy gap. So the energy required for their transition is more as compared to the other transition that are away from the nucleus. So N1 to N2, it will require the maximum or greater amount of energy. The mass number of an element is 40 and the atomic number is 20. The ratio of neutrons to proton is 1:1, 1:2, 2:1, none of the above. So here the mass number is given and the atomic number is also given. Atomic number is equal to the number of protons, while the mass number is equal to the sum of proton and neutrons. So from the mass number we will first find the number of neutrons, and the atomic number, which is equal to the number of proton, is also given. Then we will find their ratio. So the number of neutron may be calculated as mass number minus atomic number. 40 is the mass number minus atomic number is number of proton, that is 20. We will get number of neutron is equal to 20. So the neutron number is 20 and the proton number is 20. So the ratio is 1:1. So the answer is A. In a nuclear reaction, beryllium, when it is targeted with helium, it will produce carbon nuclei and neutron are released. So the X value should be 13, 12, 11 and 6. So we will balance this reaction just like the balancing of atoms in the normal reactions. Nuclear reactions are also balanced with respect to their mass number, with respect to their atomic number. So the 9 plus 4, it is towards the reactant side, it should be equal to the X plus 1, that is towards the product side. So 9 plus 4, it will produce 13, while X plus 1, it should produce 13. So X value is 12, 12 plus 1, it will be 13, and 9 plus 4, it will be 13. So the atomic number or the mass number at the reactant side, it will be equal to the mass number or atomic number towards the product side. So the answer is 12. The energy of an electron in the first Bohr orbit of hydrogen is 13.6 electron volt, minus 13.6 electron volt, 1.36 electron volt, minus 1.36 electron volt. So 13.6 minus 13.6 divided by n square electron volt, this is the formula for calculating the energy of an electron in an orbit. For n is equal to 1, because here the first orbit is given in the question, so n will be taken as 1. So n square, that is equal to 1 square, minus 13.6 divided by 1 square, it will result in minus 13.6 electron volt. So the B is correct answer. The energy of hydrogen atom in its ground state is minus 13.6 electron volt. The energy of the level corresponding to n is equal to 3 is minus 4.53 electron volt, minus 2.265 electron volt, minus 1.51 electron volt, none of these. So the formula of calculating the energy of an electron in nth orbit is minus 13.6 divided by n square electron volt. Here n is equal to 3, that is given in the question. So we will take n over there, that is equal to 3, and square is given in the formula, so 3 square will be written over there. Minus 13.6 divided by 3 square will produce 9, so we will get minus 1.51 electron volt. That is the answer. E is equal to minus 13A 11.8 kilojoule per mole. If the value of En in is minus En may be any n orbital, any n orbit, minus 52.44 kilojoule per mole, to which value n correspond? 2, 3, 4, 5. The energy values are given, so we will find the number of orbit, whether it is 2, 3, 4 and 5. So the formula will same, just we will arrange it. The value of energy that is for nth orbit, that is for example 4, 5, 6 orbit, that is equal to minus 52.44. And the energy that is given in kilojoule per mole, that is a fixed value, minus 1311.8 divided by n square. This is from formula, just like in electron volt, minus 13.6 divided by n square. Here it is in kilojoule per mole, so the in kilojoule per mole its value is 1312 or 1311.8 divided by n square. Rearranging this formula, because we are finding the n square, n value, so n square will be equal to putting the minus 52.44 over there. So we will get 25.01. This 25.01 is value for n square. Now we will take the square root. So by taking the square root, we will get n is equal to 5. This means that the energy correspond to the fifth orbit. The third line in the Balmer series correspond to the electronic transition between which Bohr orbit in hydrogen, from fifth to third, from fifth to second, from fourth to third, from fourth to second. For the third line of Balmer series, the transition should take place. We know that the Balmer series, the lowest energy level is 2. And here the third level is required, or third line is required. So we will add 3 plus 2, because the lowest level is 2, and we will add 3 into 8. So 2 plus 3, it will produce 5, which means that the from the fifth orbit, the electron will jump from the fifth orbit to second orbit. The third line will be produced. Or we can also solve it as, from third to second, the first line will be produced. From fourth to second, the second line will be produced. And the third line will be produced when the electron will move from the fifth to second orbit. So the third line will be produced from fifth to second orbit.